All right, guys, so this is Miss Murphy. I completely forgot to record this during my actual class, so I'm just going to make a quick recap of the notes from today. So today we were doing 7.2a, which had us doing multiplying polynomials, specifically multiplying a monomial by any other type of polynomial. So remember, a monomial is a polynomial with only one term, and it can be multiplied in this case to anything, whether it's a trinomial, binomial, polynomial, whatever. So real quick, if you did not get the I can statement for 7.2a, it is I can multiply a polynomial using distributive property. All right, so this is fairly straightforward. Not really much you haven't done before. So we're only looking at the tab in your foldable where it says monomial by a polynomial. So again, to multiply a monomial by a polynomial, and just remember monomial means one term. It's a one-termed polynomial. You use the distributive property. So that means you multiply whatever that term is to every other term in the parentheses. Now, there's two ways that I like to do this. So, like, for example, one, you can do it ye old-fashioned way and just do your little draw over method. Or for some of my students, if you were in my class and we did the factoring, the algebra tiles activity, the box method may work for you. So the way the box is set up is you do whatever your two factors are. So 5x is one factor, x minus 7 is another factor. And remember, factors are basically the two numbers that you're the two or more numbers, expressions, whatever, that you're multiplying together. So you put your first factor on the side and your second factor across the top. Now you want each term of your factor to line up with a box. So if you have two terms in a factor, make sure you have two boxes. If you have one term, make sure there's only one row. So since we have a one term times a two term, we have a 1 by 2 box. Now, we can then multiply where the columns and rows overlap together. So for this one, we would do 5x times x, which recall your exponent rules. So if you have 5x times x, remember exponent rules, you're adding your exponents. So you'd have 5 times x plus x times x, that's 1 plus 1, which is 2, so x squared. So this would be 5x squared. And then negative 7 times 5x, if you do negative 7 times 5, that's negative 35. And slap an x on it. And then all you do is just bring out your box. What's in your box? This would be 5x squared minus 35x. And if you did the distribute method, you would do 5x times x, still 5x squared, 5x times negative 7, negative 35x. So the box method is a bit more of a visual representation. If you like the visual representation and the separation, by all means do that. If you like just the old-fashioned way for distributing, do that. It's completely up to you. All right, so for number 2, again, you can either do the old-fashioned way or you can do the box. So I'm going to show you guys through the box. So again, we're doing 1 by 2 terms, so this would be a 1 by 2 box. So I'm going to put my one term on the side. And I'm going to put m for one of the columns, plus 9 for the other column. All right, so then for here, we're doing negative 2 times m. Remember, exponent rules, you're adding those exponents together, so negative 2m squared. And then for this one here, we're doing negative 2m times 9. So just negative 2 times 9 is negative 18, and then you slap on an m. Then when you bring everything out of the box, you get negative 2m squared minus 18m. Then number 3, again, you can do the old-fashioned distributive method, or if you like, you can do a 1 by 2 box, because you have a 1 term times a 2 term. So I have 4d squared, d in one column, plus 3 in the next. So 4d squared times d, be very careful about this. Remember, you're still adding exponents. So if this is 1 times 4, that's still 4. D squared and d the first, you add those two. So this would be d cubed. So this would be 4d cubed. Then 3 times 4d squared. 4 times 3 is 12, and then you slap on a d squared. So when you bring it out of the box, included its signs, it'll be 4d cubed plus 12d squared. Now, this method will work for just about any type of monomial times a polynomial. So these were strictly a monomial times a binomial. Those were the first 3 examples. So a 1-term polynomial times a 2-term polynomial. Now, if you look at number 6 on your foldable, as you can see, you have a monomial by a trinomial. So a 1-term polynomial times a 3-term polynomial. So be careful with this. So you can do your distributive method. Or if you like the visual, you can make a box. And again, since you're doing 1 term by 3 terms, you want a 1 by 3 box. So that's how you figure out how big you need to make your box. However many terms is in your first factor, so 1 term, and however many terms is in your second factor, which is 3 terms, so a 1 by 3. So I would have negative 7y cubed on the side, 8y squared over one column, plus 9y over the other, and minus 1 over the last column. Make sure you keep your signs when you're placing things on top of the box, just so you know that they're there. So if we work through this, again, remember your exponent rules. So negative 7y cubed times 8y squared. Negative 7 times 8 is negative 56. And you're adding these two exponents. So 3 plus 2 is 5, so y to the 5th. So this would be negative 56, y to the 5th. Negative 7y cubed plus 9y. Negative 7 times 9 is negative 63. Y cubed times y to the first is y to the 4th if we add those exponents. Then negative 7y cubed times negative 1, all you do is just change the sign of the negative 7y cubed, so it would be positive 7y cubed. And then you just take it out the box. So this would be negative 56 y to the 5th minus 63 y to the 4th plus 7y cubed. And that's really all there is to it.